Alright, so in this video I'm going to be talking through pages 17 and 18 in the notes packet. This is where we're going to talk about amortization, which is probably a new word for many of you. But let's break into what that actually means. So up until now, we have assumed that there's no money being put in or taken out of an account while it's earning interest, right? When we talk about compounding, there's just an initial value. It earns interest until the end of the term. Right, that makes the math very simple, but that's also pretty unrealistic, right? Most of the time when you have something compounding interest, you're also adding money or taking money away. And if you're doing so at an irregular rate, then the math gets really complicated, but we can handle consistent payments, right? That's a very tractable problem. So that's what we're talking about with amortization. We're going to learn how to model financial amounts that are growing or shrinking based on consistent payments being put in or taken out. And like adding this to our models allows us to talk about a lot of new applications. So some of the ones you'll talk about would be like car loans or mortgages, or if you're trying to pay off your credit card debt with fixed monthly payments. We can model all that using amortization, or the math we're going to use to understand amortization. Investment schemes that involve investing money at a fixed amount or investing a fixed amount of money at consistent intervals. So if you want to try and invest by like depositing, the same amount into an investment each month, which is something I highly recommend doing, we'll learn how to analyze that. And annuities, where basically it's an account that's earning interest and you're also drawing a consistent amount from it. This is very much tied to retirement. So some vocab, we're talking about loans, right? If you're borrowing to buy a car, you're borrowing to buy a house, then you need to pay off the loan. Amortization, the process of dividing the repayment of the loan into consistent monthly payments. To amortize means we're doing the process of amortization, right? Taking that whole loan amount and making it, like breaking up into consistently monthly payments. And we'll also be talking about annuities, which is an investment product where people basically invest money into it and then they retire. And when they retire, they get fixed payments from it. So it's a way to smooth your income throughout your lifetime, where you take a little bit less income now because you're putting money into this account, but then when you retire, you have consistent payments from it. So it's a very common retirement strategy, and we're going to be studying how that works. And the good news is we can do all of this right in our TMV calculator. So we had those two things that I told you to ignore when we were doing the previous problems, the PMT field and the PY field. So this one here and this one here. So the PMT, that is the monthly payment amount. And just as with the present value, how we have how negative numbers means you're putting money into it, so you always make it negative. The same thing goes for the payment amount. So if you're talking about putting money into the investment or into the account, then that's a negative number because it's a negative cash flow for you right now, right? You are putting money into it, meaning your cash in your pocket is decreasing. If you're taking money out of it, then you need a positive value because then it's positive cash flow. Then it's being withdrawn. It's money going from the account into your pocket, so it's positive. And then PY is the frequency of payments. So you have a payment amount, and then PY is the frequency of payments. Everything else remains the same. And so this will help us answer new types of problems. So for example, we look at Damien, currently has $2,000 invested in a bank account that earns 4.3% interest compounded monthly. He plans to add $100 each month to this account in order to build his savings. Determine how much money he would have in his savings if he successfully follows his saving plan for 5 years. And so we see the values are already in there, but let's go to the calculator and put them ourselves. So, and it's monthly compounding over 5 years, so that's 60 compounding periods. The interest rate is 4.3. He already has 2,000, so that's his kind of present value. That's the initial amount investment, but he's also investing an additional $100 each month. And we want to make sure that the payments are monthly and the compounding is monthly. and then we go alpha, enter on value, and we can see that he will have accumulated at the end of the 5 years $9,159.30. And I put this little blurb here, this little bonus concept, as just the way that I like to think about like the intuition behind a problem like this, is breaking up this total value into the different payments and how long they've been accruing interest for. So that initial $2,000 is accruing interest for the entire 5 years. Then there's also the first $100, which earns interest for 59 months, right? It doesn't for that first month, but it does for the rest of the 5 years. And the second one for 58 months, and then so on, all the way up to the final $100, which was just invested at the end of that 60th month, and so it has not earned any interest yet. So if you think about this as like the sum of those kind of, 61 discrete payments, which have all been earning interest for different amounts of time, you put them all together, and that will give you this value. All right, let's do an example of a credit card or of a car loan and how you take debt and you turn it into a monthly payment. So these are true numbers, by the way. I took this from my own life. So Mr. Ninto took out a loan of $19,370.50 to buy his Mazda CX-5 at an interest rate of 6.41% compounded monthly. Pay off this car loan over the next 5 years by making consistent monthly payments. Use the TMV calculator to determine his monthly payments. So if we're doing monthly payments over 5 years, that means that we have 60 compounding periods. We know that the interest rate is 6.41%. Well, the present value, that's going to be negative what I currently owe. PMT, that's what we're trying to find, right? We're trying to find the payment value. For future value, we're trying to figure out, so the future value, if you think about what we want to put here, we're trying to figure out when will this value go down to 0. So for the future value here, if you want to figure out when the loan will be completely paid off, you put a future value of 0, right? When is it gone? And then it's compounded monthly, so PY and CY are both going to be $12. And let's go in here. Still at 60. Change this to 6.41. Change this to negative 19,370.50. The payment, that's what we're trying to figure out for a future value of 0. And if we do alpha enter, we see that Mr. Ninto needs to pay $378.19 a month. So $378.19 per month. All right. So now if we go down to example 3, we have Mrs. Williams saved for retirement by investing $300 a month into an annuity account that paid 3.5% interest compounded monthly for 40 years. Now that she is retiring, she'll start making consistent monthly withdrawals from the retirement account to pay for her living expenses. So we have two things going on here, right? First of all, as she's working, she's accumulating money in her retirement account. Once she retires, she's going to pull money from that retirement account. So let's start by just using the TMV calculator to figure out how much money will be in her retirement account when she retires after working for 40 years, right? Putting $300 a month into this account for 40 years. Let's see. So 40 years at 12 months per year. That's going to be 480 total months that she was putting money into this, earning 3.5% interest the whole time. The present value, so here, it doesn't say that she had any amount in the account to start with. Right, that's an important thing. There was no money in the account to start with, so the present value is 0. For the payment, she's putting in $300 each month, so we put negative $300. The future value is what we're trying to find, and then PY and 3Y, or PY and CY, those are both 12 because we're dealing with monthly compounding. All right, so now if we go here, we go up, we want to change this to be 480, interest rate 3.5, present value 0, payment negative 300. So let's see, after 40 years, that amounts to $313,400.07. So $330,000 or $313,407. All right. So if she hopes to use this retirement account to support herself for the next 25 years, how much money can she withdraw from this account each month? All right. So 25 years, 12 months a year, that's going to be 300 total months. I think I did that math right. Yep. The interest rate, she's still earning 3.5% interest. The present value, so at this point, the initial value, right, what we're starting with, well, that's what she had in her account after working for 40 years. So that is $3,113,407. The payment, that's what we're trying to find. The future value, well, she wants to use this account for the next 25 years, meaning in 25 years, we can draw the account down to 0, right? We can use that as our final amount. PUI and CUI, those are still going to be 12. Let's figure out what monthly payment can she afford to draw out of this account to make it last for 25 years. So now N going to be 300, I still 3.5. The present value is now, so we need to make this negative, 313,400.07, or we can do 0.0615. Your answer is, it's going to make a very small difference. So either way is fine. For the payment, that's what we're trying to solve. The future value, we're seeing when will the account, assume the account will be 0 after 25 years. If we do alpha enter, we can see that she can withdraw $15.68.95. So her monthly payment, that can be $1,568.95. All right, I think I'll leave that for a different video.